What will be the direction of the differential displacement of P1 with respect to C? The differential displacement of point P1 with respect to center of mass will be either in this direction or in this direction, depending on omega of the rigid body. So you can see that it will be perpendicular to the direction of the parallel component of the force. So it will reduce to finally F1 perpendicular and this is nothing but R1 d theta. If you want to write this in vector notation, what is this? Torque due to force F1 in dot product with d theta. It will take care of the sign as well. Even if omega is in this direction or in this direction, d theta vector will be in the direction of omega. You need not write tau or torque due to F1 perpendicular. Torque due to F1 itself will be this, because anyway the parallel component will not produce torque. So you can see that this reduces to tau F1 or here this is tau F1 dot d theta. So if you add the differential work done, what will you get? So net differential work done by all the external forces put together will be differential work done in rotating the rigid body because of the torque produced by all these forces, and differential work done in translating the center of mass of the rigid body. Now what about the internal forces? We have already seen in system of particles that here this summation of all the internal force. Similarly, if you write differential work done by internal force at points P1, P2, etc., this summation of the internal forces will become 0. So the net effect for the translational motion will not be there. Then what about this component? We have already derived for system of particles that the net torque provided by all the internal forces on the system of particles is 0. So if we extend for a rigid body, then the net work done depends only on the external force, and if you integrate, you